Hello, everyone. My name is Khashayar Sadeghi. I'm the faculty member of Polytechnic University of St. Petersburg and a postdoc researcher at Polytechnic of Milan. I'm so delighted that today I have the opportunity of being with you for giving a lecture about the hydrogen production and especially nuclear hydrogen production. We are going to talk about fundamental of nuclear hydrogen production, and I hope that you can gain enough information about this topic. So in this lecture, we are going to talk about 5 important topics. The first one, we are going to talk about the role of hydrogen in energy transition, and I'm going to give you an introduction about this topic. After that, we are going to talk about the main methods of hydrogen production. Of course, we don't have enough time to talk about all details of this topic, nuclear hydrogen production or generally hydrogen production is a very widespread topic, and of course we don't have enough time for that. Just I'm going to give you the fundamental information about this topic, and if you are interested in that topic, you can continue it for your education or in your future career, and I'm sure that this lecture can help you in that field. As a next step, we are going to talk about the nuclear hydrogen production, different schemes. We'll talk about this topic and a little talk about the safety of nuclear hydrogen production, because you know that safety of nuclear hydrogen production is really important because we are talking about the nuclear power plant, and accidents in nuclear power plant is a general and global concern among all governments and universities and researchers. And finally, we are going to talk about the methods for techno-economic evaluation of nuclear hydrogen production. We'll talk a little about 2 important tools for techno-economic evaluation. So with that being said, let's start our work with an introduction about the energy consumption in the world. First of all, we should understand what is the role of hydrogen and how hydrogen can help us to improve our environment and get to net zero emission goals. We will talk about net zero emission goals in future. So according to this slide and the figure at the left side of this slide, you can see the world energy consumption by different sources. As you can see, the liquid sources, energy sources, like for example gasoline, they have the maximum share of energy consumption in the world. And for example, nuclear, you can see nuclear doesn't have a very significant share in comparison to, for example, natural gas, coal, or liquids. And you can see that in future we expect to have an increase in using or consuming renewable energy sources, and in addition nuclear energy. At the right side of this slide, you can see this share in percentage. As you can see, the renewable energy source in future, the projection of consuming renewable energy sources in future has a significant amount, and for example, for nuclear, we don't have such a sharp increase in consuming this energy. So when we talk about the energy consumption, especially about the consuming liquid energy sources, we should talk about the carbon dioxide in addition to greenhouse gases. So what is the carbon dioxide? If you want to talk about carbon dioxide, we should talk about greenhouse gas. What is that? Greenhouse gas is, it's formed of 3 main components, and as you can see in the table, carbon dioxide, methane, and nitrous oxide. These are 3 main components of greenhouse gas, and in this field, carbon dioxide is the most important one for us because, as you can see, the percentage of emission in all over the world. Here we have an example for Canada, but in all over the world is very, very high. Almost 80% of all greenhouse gas is carbon dioxide, and it's very important for us to consider this emission. Here we have a very important definition. We want to talk about carbon dioxide, but for carbon dioxide, we have definition of net zero emission. What is that? Net zero emission means that the rate of producing carbon dioxide in the environment should be equal to the rate of absorbing or removing carbon dioxide from the environment. And if we have a balance between consuming and between absorbing or removing carbon dioxide, then we can say that we get to net zero emission goals. But there is a difference between net zero emission and carbon emission, zero carbon emission. Zero carbon emission means that you shouldn't produce any carbon dioxide in your industry, in your power plant. But net zero emission means that you can produce carbon dioxide, but at the same time you have to remove this produced carbon dioxide. So what is the disadvantage and drawback of producing carbon dioxide? As you can see in this slide, rising maximum temperature and rising minimum temperature, so it's a very, very important concern, and we should think about it. Or rising sea levels. Generally, I can tell you that increasing the amount of carbon dioxide in the environment can trap the heat under the atmosphere, and of course the temperature of the earth will be increased, and it's a very, very important problem that we should think about it and find a solution for that. In this field, regarding the net zero emission, hydrogen can play a significant role to get this goal, to get to the net zero emission goal. Hydrogen is the most abundant isotope in the world, and consuming this isotope as a fuel can remove a lot of produced carbon dioxide from Earth, and of course it helps us to get to the net zero emission until 2050, because you know that the main goal of net zero emission is specified for 2050. According to the Paris Agreement, we should try to remove all, or not remove, better to say, to get to the net zero emission by 2050. And hydrogen as a fuel, as a very clean fuel, can help us to get to this point. So what is a hydrogen? As I told you, hydrogen is our most abundant isotope in the world, and this isotope had three different isotopes, let's say three different isotopes, H1, H2, and H3. And when we talk about the hydrogen production, we are going to talk only about H1, the first isotope of hydrogen. H2, deuterium, also is another isotope of hydrogen, but we are not going to talk about this isotope. And H3 is a kind of radioactive and unstable isotope, and of course we are not going to talk about this one also. We have different methods for separating hydrogen from different material, different molecules, like for example water, and in next slide we are going to talk about them by a little details. So before talking about the main methods of hydrogen production, and especially nuclear hydrogen production, let's talk a little about the main application of hydrogen in nowadays in the world. So you can see that according to this slide, 55% of all produced hydrogen in the world is going to be used for ammonia production, and 25% can be used in petroleum refining. And you can see that for transportation or the other thing, only 10% of produced hydrogen can be used. And it means that we have a very perfect and great opportunity for increasing the utilization of hydrogen in the world. Main methods of hydrogen production. In this slide, you can see at the center of this slide, you can see the primary energy sources. Of course, you know that we have many different energy sources, like uranium, that is the main fuel for nuclear energy, solar energy, geothermal, hydro, biomass, gas, oil, coal, generally fossil fuel. So these are all the primary energy sources, and we have two options for consuming these energy sources. The first option is traditional utilization. It means that you burn, for example, you burn fossil fuel and you produce some energy, and you use this energy for different applications. So this is the traditional application of primary energy sources. But at the same time, we can use these energy sources in the other form. We can produce hydrogen from these primary energy sources. For example, by using uranium, we can produce heat and electricity. Okay, so heat and electricity, we can use them directly in different applications. But it should be noted that using produced heat and electricity of uranium we can produce hydrogen. I will explain you later by means of which method we can produce hydrogen. But using heat and electricity produced by uranium, we can produce hydrogen. For example, method of electrolysis or method of thermochemistry or chemical reformation. Generally, I want to say you that by using different energy sources, we can produce hydrogen, and it depends on the method of hydrogen production. For electrolysis, usually we use electricity, but sometimes we can increase the performance of the electrolysis and give some heat to the water and increase the temperature of water, and then the efficiency of the electrolyzing will be increased. Or for example, chemical reformation, for example, steam reforming or carbon dioxide reforming. All these reactions, they need energy, they need heat. So we can provide this heat from these energy sources. So now we want to talk about the nuclear hydrogen production, but before that, probably you don't have enough information about nuclear power plants. So in this slide, I'm gonna give you some information, very, very basic information about nuclear power plant. Nuclear power plant is completely similar to not completely, of course, it's very similar to a traditional power plant. Just there is a difference in a traditional power plant or thermal power plant. We only burn fossil fuel, but in nuclear power plant, we have a reactor, and in the reactor we have nuclear fuel, and by consuming this nuclear fuel in some ways that is not important for our lecture, we can produce energy. And this energy can be removed from the reactor by some kind of coolant, like for example water, and this water then goes to the turbine, goes to the steam generator, then we can produce steam, and the produced steam goes to turbine building, then by rotating the shaft of turbine, and we can produce electricity. So this is completely, the scheme is completely same as a traditional or thermal power plant, just the most important point is replacing a boiler with a reactor. We can classify nuclear power plants to different groups, and based on different parameters, we can classify nuclear power plants. For example, classification by coolant, type of coolant, classification by type of moderator, or the other things. But here in nuclear hydrogen production, we are going to go through the classification by generation. What does it mean? We have a different generation for nuclear reactor. The first generation reactor, it was for, like for example, just after a Second World War, and some kind of very, very famous reactor like Fermi reactor. It was the first generation, very, very simple, without any, let's say, digital instruments and the other things. So it was very, very simple reactor. After that, government decided to develop their technology and produce energy from nuclear power plant. So the second generation of nuclear power plants, like for example, PWR or VVER, the Russian version of PWR, or CANDU or RBMK, they were developed to produce energy. After that, by developing the technology, we experienced the third generation of nuclear power plants, like for example, ABWR, Advanced BWR, Advanced PWR reactors, or EPR. The most important difference between this generation with previous one is increasing the safety aspects of the reactor, in addition decreasing the cost of the nuclear reactor. So after that, we had third plus generation, some kind of, like for example, advanced VVER, or again advanced PWR reactors. Again, we worked on the cost and safety of the system. And finally, fourth generation. Fourth generation is a very, very promising technology, and we have some kind of nuclear reactor based on fourth generation. The most important property of fourth generation reactor is the operating temperature of these reactors. Most of these reactors, they can operate in a very, very high temperature, like for example 600, 700, 800, and this temperature can provide a unique opportunity for producing hydrogen, because you know that for producing hydrogen we need a huge amount of energy. So these kind of reactors, I mean fourth generation reactors, they can provide a unique opportunity for nuclear hydrogen production. In this lecture, we are going to talk about both of them, I mean fourth generation and third generation, and I will tell you how we can produce how we can produce hydrogen using the third generation or fourth generation reactors. nuclear power plant is not used only for producing electricity, and we have different application, many different applications by nuclear power plant. The reactor that's the nuclear power plant that not only produce electricity but also produce heat for many different applications is called cogeneration plant. Means at the same time we can produce electricity and heat. So for cogeneration plant we have two different categories. The first one is low temperature cogeneration and the next one is high temperature cogeneration. In low temperature cogeneration we can use low temperature steam extracted from turbine for district heating, for seawater desalination, and low temperature industrial process heating, and in addition for low temperature electrolysis for hydrogen production. In high temperature cogeneration we can use high temperature steam extracted from high pressure turbine of the nuclear power plant for high temperature industrial process, and the most important application for hydrogen production, especially for high temperature steam electrolysis that we're going to talk about it later by details. So in this scheme you can see the application of a nuclear power plant. As you can see, we have three main lines from here. Radiation, so we can use the radiation for different applications like medical isotopes, and the other thing that is not in our lecture today, is beyond the scope of our work today. Then we have heat, so from this heat we can produce, have thermal heating, process heating, district heating. You can see seawater desalination, and at the same time we can produce electricity, and in this electricity can be given to the grid or the network of the city, or can be given to the for example seawater desalination plant or nuclear hydrogen production. So you can see we have many different applications for nuclear power plant. In this scheme, you can see a general scheme, a very general and typical scheme of nuclear cogeneration plant. You can see that by extracting steam from low pressure turbine and giving this steam to the intermediate loop number 12. Here we can use the heat of this extracted steam, and for example in this scheme we have a seawater desalination plant, but no different. You can instead of seawater desalination plant you can put a nuclear hydrogen system or hydrogen production system, and this is a very general scheme for combination of secondary system to the nuclear power plant, integration of them. And of course we have many different schemes for combination of secondary system to the nuclear power plant, and we should have a kind of optimization for that. Nuclear hydrogen production methods, here you can see we have heat and electricity from nuclear reactors. So the produced electricity can be used in low temperature electrolysis, and also in addition to the high temperature electrolysis. I told you in low temperature electrolysis the temperature of water is less than 100, but by increasing the temperature of water, by increasing this temperature, the required electricity for electrolysis decreases. So it's a very good option because we know that electricity is more expensive than heat. So if we consume heat to increase the temperature of water and consume less electricity, it's a very good option, and it's a very positive point for us. The next method is thermochemical electrolysis, thermochemical reactions. In thermochemical reaction, you should perform several interactions, reactions, and produce hydrogen, and it takes a lot of energy. So for this method, we have to use fourth generation reactors because the produced heat and temperature in this kind of reactor is very high. Sometimes we can use steam reforming or carbon dioxide reforming. Again, we need a huge amount of energy, and fourth generation reactors, they are the best option for us regarding this issue. As I told you, the fourth generation reactors, they are underdeveloped nowadays, and here you can see the main type of reactors, fourth generation reactors. Gas cooled fast reactor, of course the coolant here is gas cooled. Lead cooled fast reactor, again here the coolant is not water and is a lead. Molten salt cooled reactor, molten salt fast, this is a fast reactor, and the coolant in molten salt. Molten salt, the temperature can be get to 600, 700, 800, so it depends on the design. sodium-cooled fast reactor, supercritical water-cooled reactor. In supercritical, the temperature can be increased so much, like for example, in light water reactors, typical reactors like VVR or PWR, the temperature is not greater than 320, 330. But in supercritical reactor, the pressure will be increased so much, like for example, 22 to 23. It should get to the critical point of water, and then you can increase the temperature of water. So it's a good option. The efficiency of this system in comparison to typical VVR or PWR reactors is higher. And finally, high temperature gas cooled reactor, that is a very good option for any type of hydrogen production method. In this scheme, you can see, in this slide, you can see two different reactors. Very high temperature gas cooled reactor that I told you, combination of this reactor with hydrogen production unit. As you can see, the gas, for example here, helium, comes out from the reactor and goes to the steam generator. Water, by passing through the pipes of the steam generator, will be turned to the steam, and the produced steam goes to the, let's say, hydrogen production unit, and we can produce hydrogen with that. And the next picture is gas-cooled fast reactor for hydrogen production. Again, here we have the coolant is a kind of gas, and gas goes to the turbine and rotate the shaft of the turbine directly and produce energy and electricity. So we can use this produced energy and electricity in addition recovering the heat of the coolant. We can use it in hydrogen production unit. So for techno-economic evaluation of nuclear hydrogen production, we can suggest two different codes and programs. One of them is HYSYS. Aspen HYSYS is a very, very powerful program for simulation of thermal scheme in the nuclear power plant. And for economic evaluation, we can use HEAP. This program is developed by IAEA and is a very useful program for economic evaluation of hydrogen production. So the most important point here is combination of technical analysis and economic evaluation. So we should think about it. How is it possible to combine them? And we should, after performing a technical analysis, we should extract and we should take some parameters and take these parameters to the economic evaluation and obtain the final cost. And the best criteria for selecting the best option and the best method is cost. So we have to perform a techno-economic evaluation for nuclear hydrogen production. And finally, I want to talk with you about the Center of Nuclear Advanced Technology at Polytechnic University of St. Petersburg. In this center, we have many young researchers that they are working on different directions of nuclear energy and nuclear science. One of them is nuclear hydrogen production, and in this center, we have developed some algorithms, programs, and we have published several articles in this field, and now we are working on this topic extremely. Thank you very much for your attention. I hope that this lecture gave you enough information and general information about nuclear hydrogen production, and you can use them in your future education and future career. Thank you very much.